Hi, everyone. My name is Davide Stronati, and I'm the chair of the Committee on Engineering Environment at the World Federation of Engineering Organizations. It is 12 o'clock here in London, in the United Kingdom, but this is pretty much of a global event. This is a global webinar because effectively we come from the World Federation of Engineering Organizations, which is an international a non-governmental organization representing the profession, the engineering profession worldwide. The WFEO has been founded in 1968 under the auspices of UNESCO, and it wants to bring together the international engineering organizations from some of 100 nations and represents more than 30 million engineers worldwide. And today we are here with lots of members from the different standard technical committees to talk about the role of engineering in addressing climate change, mitigation of its causes and mitigation of its effects. And it is with great pleasure that I will pass now to our president, José Vieira, who is going to give a brief introduction on this at this webinar. Please, José.
Okay, thank you very much, David. I must say firstly to our distinguished speakers, Janet Moncomble, Kirils Holstovs, Valentina Putrino, Ignacio Gonzalez, Jianping, Marlene Kanga, and Don Bonfield. Dear colleagues, ladies and gentlemen, good morning, good afternoon, good evening to all of you, and welcome to this very interesting webinar on climate change. As introduced by David Stronati, I am the president of WFEO, the World Federation of Engineering Organizations, and I am very pleased to deliver this short opening address. It gives me great pleasure to open this important event whose focus is centered on the threat posed by climate change and the global challenges the international community is facing due to overlapping crises of water, food, and energy, with very significant negative impacts on socioeconomic development and people's well-being, particularly in developing countries. First of all, I would like to congratulate the WFEO Committee on Engineering and the Environment, in particular its chair, Engineer David Stronati, for holding this webinar in collaboration with other WFEO committees, namely Water, Energy, Disaster Risk Management, Education in Engineering, Young Engineers Future Leaders, and Women in Engineering. I am particularly happy to see that this event represents WFEO's effective commitment to actively building a recognized affirmation in the discussion and search for solutions to global societal challenges by bringing together different standing technical committees that together can and should deal with imminently cross-cutting issues through their specific vision and approach. Recently, on the 18th November, and following the Conference of Parties COP27 held in Sharm el-Sheikh in Egypt, the United Nations published a draft overarching decision document saying COP recognizes the impacts on climate change will be much lower at the temperature increase of 1.5 degrees Celsius compared with 2 degrees Celsius, and reaffirms the resolution to pursue efforts to limit the temperature increase to 1.5 degrees Celsius, the goal of the Paris Agreement. Recognizes the critical role of protecting, conserving, and restoring water and water-related ecosystems in delivering benefits for climate adaptation and its co-benefits, while ensuring social and environmental safeguards. Recognizes that global crisis, energy crisis, in addition to the impact of climate change, are challenging the efforts to achieve energy security. This underlines the urgency to rapidly transform energy systems to be more reliable and resilient, and the need to accelerate clean and just transitions to renewable energy during this critical decade of action. The latest UNESCO engineering report, Engineering for Sustainable Development, stresses that climate change manifested through changes in atmospheric and oceanic conditions will impose increased and new risks on many natural and human systems, notably through changes in climate variability and in the frequency and magnitude of extreme climate events. Clearly, society is facing new threats and challenges, and growing need for alternative clean energy sources, food and fresh water shortages that are prevalent in many regions of the world, and growing concerns for the environment. On the other hand, I am also sure that only by combining the forces and knowledge of the global engineering and scientific community, it will be possible to find solutions and measures for scaling up and improving infrastructure for poverty reduction and facing the challenges of global warming and climate change, both in developed countries and mainly in developing countries where the vulnerability of infrastructures and societies is most evident. In this event, we will have the pleasure and the opportunity to hear distinguished speakers from different professional backgrounds and with different approaches on the WFEO statement on energy and climate, disaster risk management, climate adaptation on water, climate change mitigation, climate engineering education, and the role of young engineers and women in engineering. This webinar promises to be informative and exciting, and I am sure that it will be a success and will have the impact that is advocated for a greater and increasingly influential of WFEO in helping the achievement of the United Nations Sustainable Development Goals. Once again, I want to acknowledge the invaluable dedication of Davide Stronati in designing and moderating this webinar, and my gratitude extends to everyone that has made it possible. I wish all of you a fruitful webinar. And now I give the floor to David to have this moderation. Thank you.
Thank you, President Vieira. And I would invite all of you to look at the chats where you can find the link to a Google document. This is the beauty of webinars, where effectively in real time you can write questions to whoever is in the panel, to whichever presenter, who is going to try to answer immediately after the presentation. So the first one is going to be Jean-Claude Moncomble. He is the chair of the Committee on Energy and Engineering. And by all means, Jean-Claude, the floor is yours.
Thank you very much, Davide. Thank you very much for this opportunity to share with you the work of the work of our committee. My presentation will be based on the statement on energy and climate change that has been written by the WFEO Standing Technical Committee on Energy. What I want to say is that this statement is mainly based on the reasoned opinions of engineering communities devoted to the design of energy systems all around the world. Following the IPCC analysis, and in particular its latest messages on the urgency of implementing not only greenhouse gas mitigation policies, but also adaptation policies to the consequence of climate change. This statement is based on all the work of our committee. First point, I want to insist on the fact that, of course, energy is at the heart of climate policies. And it is due to the resulting greenhouse gas emission and required effective action in two main directions. First, searching for greater energy efficiency and usage restraint from energy production to energy consumption. It is essential to decouple economic growth, a source of higher standard of living, from energy consumption. All the scenarios conclude that a breakthrough is essential in the evolution of global energy intensity, which must move from an annual rate of -1 to -1.5 observed historically to a rate of -4 or -5% a year. Second, decarbonizing energy systems, both on the supply side and the demand side, by promoting low-carbon technologies. These two levels can be activated by technological choices and change in behavior, and this choice and behavior could be very often encouraged by energy policies. What are the low-carbon technologies? First, renewable energies, mainly solar, wind, biomass, and hydropower, have to be applied and further developed. The fact is that none of them is without environmental consequence, sometimes less apparent than for other forms of energy, into the electricity grid. While the integration of some of them, wind and photovoltaic energy, into the electricity grid can be a source of difficulties due to their variability, others, on the contrary, are virtuous in terms of stabilizing the system. And the example is hydroelectricity with reservoir. Most of them are not very dense. Their large footprint is a source of local opposition, but they all have the advantage of having a very low carbon footprint. Second, nuclear power has a very low carbon footprint and it's stable and reliable in operation. Like hydropower, it can produce massive amounts of decarbonized electricity and thus make a very substantial contribution to energy system decarbonization. Nuclear power is essential in the fight against climate change. Also, safety and radioactive waste management are frequently cited as concern. This concern can be managed adequately at present, including the reuse of some long half-life wastes. The main challenge for energy policymakers and engineers is to restore nuclear power rightful place through information and debate. Third, fossil fuels, coal, oil, and gas, which are responsible for a large proportion of CO2 emission, still account for the largest share of the global energy mix. While it does not seem possible to eliminate them quickly and completely, particularly in certain sectors such as transport or in certain countries, there could be a transition energy when combined with carbon capture, use and storage technologies. Electrification is certainly one of the key drivers of the energy transition. Particular attention must be paid to electrical system, especially to assure base load. The decommissioning of conventional fossil power plants and the massive development of variable renewable energies may pose problems of continuity and quality of electricity supply. Backup power plants, cost-effective and efficient energy storage technologies, development of demand flexibility, and the development of electrical network will be needed to overcome the variability problem of renewables. The issue of access to energy in general and to electricity in particular remains a major challenge in many regions of the world. to which different answers are likely to be required, whether for the supply of large developing megacities or for isolated and off-grid sites. Sorry, I have forgotten. The search for greater resilience of energy systems raised a question about land use, scarcity of water, or use of raw materials like copper, lithium, nickel, cobalt, zirconium, platinum, and some other rare earth elements. It might lead to their early depletion. The shift in dependence of energy systems, both on the supply and demand sides, from fossil fuels to some raw materials, some components or equipment, is a new challenge, and to which we have to answer, to which answers must be found, particularly in terms of circular economy and industrial development. Effective national energy policies and international cooperation will be essential to implement the most effective policies to achieve the net zero emission goal. While it is undeniable that developed countries still account for a large share of emissions, 33% in 2021 compared to 40% in 2011, demographic trends highlight the major role of developing countries. In 2050, there will probably be nearly 10 billion people on the planet, compared to about 8 billion today. And this growth will be observed mainly in developing countries, which will account for 87% of the world population. The search for solutions must be based on a prospective vision of energy consumption, marked by an aging population and increasing urbanization and associated emissions. Climate policy choices, including support by developed economies to developing ones, cannot be conceived outside a global framework and effort. The choice to focus on solutions that contribute effectively and immediately to the fight against climate change should not make us forget. First, the indispensable research effort to develop medium and long-term solutions that will find their place in the future, like, for example, facilities using decarbonized hydrogen, other zero-carbon fuels, improve efficiency in electric mobility and buildings, storage technologies, including use of the peak grid electricity, solar power towers, small modular reactor, and nuclear fusion. Regarding very low carbon hydrogen or synthetic fuels, further R&D needs to be carried out to deal with usage difficulties, including storage safety and flammability risk, before full use of its potentialities could be implemented. Second, the increasing need to adapt the economies, and in particular the energy system, to climate change in order to protect the energy production facilities from the threat of rising sea level and extreme weather conditions. The consequences of climate change are already being felt on river navigation, irrigation, hydropower, and thermal plant cooling. Third, the link between energy and the Sustainable Development Goals. The search for solutions provided by engineers sometimes lead to energy choices that are in conflict with other sustainability requirements, such as biodiversity and production of indigenous people habitats. The path towards sustainability energy system will require rational and rigorous method for making choice, far from any dream or ideology, and should be based on the following principle. A, adopt a systemic approach. B, exploit the best mature technologies and associated capacity building, whilst also encouraging innovation and new technology development. C, emphasize the real potential of any new technology, its adaptability, and the easiness to transfer such a technology. D, give more importance to economic efficiency when global economic and social crises provoked by unforeseen situations leave all actors under financial constraint. And of course, we are thinking to COVID-19 crisis and Ukrainian war. E, implement more international cooperation between developed and developing countries in the fight against climate change. Last, it is essential to have a balanced approach between economic progress, social justice, and environmental preservation that is fundamental to energy security of a country. This is also a sine qua non condition for the acceptance by the citizens of the country to implement energy and climate policies. Thank you very much.
Thank you very much, Jean-Claude. I think it's not by chance that effectively the Committee on Energy was the first one to talk in this webinar, because effectively Jean-Claude very clearly described the complexities of energy policies and the links with climate change. Now, the second presenter is going to be from the Committee on Young Engineers and Future Leaders. His name is Kirils Holstovs. And Kirils, I invite you to talk and present the role of young engineers at the recent COP.
Many thanks, Davide. So I'm a young civil engineer based in the United Kingdom and a member of the Young Engineers Future Leaders Standing Technical Committee, and specifically the working group on SDG 13, which is climate action. So a brief overview of the presentation will tell you what our working group does, who we are, the aims of the working group, and the outcomes that we've been able to achieve both at COP26 and COP27. So firstly, our working group, which specializes in climate actions, sits underneath the Young Engineers Future Leaders Committee, and it was formed just before COP26, where we saw an opportunity to utilize the expertise and the voice of young engineers to help drive the ambition of climate action and really promote the necessary solutions to climate action. So members of our working group pretty much cover all continents, and as you can see at the moment, we have 8 active members, and the group is currently having plans to expand. The current chair of the group is Christopher Chikunte, who is from Nigeria and based in Canada, and we also have members from New Zealand, from other countries in Europe, from including the UK, including Latvia, myself. We have a person from South Africa and a person from the United States. So the aims of the working group is firstly to enable and enhance participation of young engineers in policymaking, and particularly relating to the United Nations Sustainable Goal 13, climate action. And secondly, foster cooperation of the global young engineers community and represent their voice in climate action. So our working group was formed just before COP26, and one of our main initiatives for COP26 was the joint statement of international youth organizations. So as young engineers, we saw this unique opportunity to provide a unifying voice to some of the most influential UN-affiliated youth organizations, which include YOUNGO, the official UNFCCC constituency, youth constituency, the Global Youth Climate Network of the World Bank, members of the UN Secretary General's Youth Advisory Group on Climate Change, major group for children and youth science policy interface platform, and finally, of course, our working group. So this declaration provided 12 overarching climate policy recommendations and was unprecedented in its nature because no other declaration beforehand tried to unify the voice of all those major groups. And we received a number of endorsements from major international organizations, and were advised by policymakers on how to best structure this to provide as effective policy recommendations as possible. So we came to this declaration, to COP26, and it was showcased at two events, and we also engaged in a number of meetings of senior policymakers. So here you can see some of the photos where we personally presented the declaration to the COP26 presidency, to the United Nations Secretary General, to renowned scientists, to the high-level champions, and to senior politicians. We also were successful in securing several bilateral meetings, which were quite constructive in their nature when we had an opportunity to sit down with the lead negotiators and really constructively discuss the policy recommendations coming from the global young engineers community with the support of the wider youth and international engineering organizations. And this declaration was also showcased in some international press and industry coverage as well. And building on from the success for 2022 and our preparation for COP27, the working group has set out the following priorities. So it was continue the client policy recommendations stream and engage in advocacy, then use our experience to help build capacity of youth and young professionals to help elevate their voices. Then thirdly, represent the voice of young engineers and enhance youth engagement decision-making. And finally, continue to build and enhance partnerships to build our influence and advance climate action. So in advance of COP27, based on our experience in the relationships that is built, we've created a capacity building session where influential young leaders, including a G20 youth delegate, the COP27 youth envoy, members of our group, and our partners from COP26 shared their experience on what effective participation in COP27 for youth could look like. And we shared our experience and tried to answer as many questions from young leaders as we could to prepare them for the upcoming summit. And then for the actual COP27, we engaged in a number of events, including in the first ever Children and Youth Pavilion, also the Paris Committee on Capacity Building Hub, and SDG Pavilion, where we showcase some of the solutions that we, as young engineers, were working on, and some of the solutions that the engineering industry in general can provide. Also engaged in a number of meetings of senior policymakers, and also closely aligned ourselves with our partners in the Commonwealth, which represent a significant proportion of the global population and a very diverse spectrum of countries and people. So here you can see members of our working group speaking at several of the events at Children Youth Pavilion and the PCCB Hub. We also we continue to elevate the voice of young engineers on major international platforms, including a feature in the World Economic Forum, where we really emphasize that young engineers have been driving innovation for years, and there will be their inclusion in climate action decision-making is absolutely imperative in order to help address the challenges that we are facing. Also, we're closely aligned with some of the major youth policy platforms, and one of our members, Michaela Chan, was the UK youth delegate to the G20 youth platform, and she actively worked to represent the voice of young engineers and contribute to solutions in the sustainable development workstream. And this culminated in the Y20 communique, which was then sent to all the G20 countries and of course promoted as wide as possible. And as you can see on the photo in the top right corner, Michaela also personally delivered this communique and their policy recommendations to number 10 Downing Street. One of our main events for COP27 was an official Blue Zone side event, which was our first experience in organizing such a major event for COP. And we had a number of major international platforms, which you can see below. And notably, we also secured the formal endorsement of the Commonwealth Secretariat, and the event was promoted by them. And from the engineering's point of view, the event, of course, was supported by the World Federation and also International Federation of Consulting Engineers, who partnered with us. And with this event, we brought together 4 senior policymakers and 3 young leaders in the areas of climate finance, engineering, and scientific research to showcase how young people how young people's expertise can be used to bridge the science policy divide and really to help accelerate climate action with the necessary solutions. So in advance of this event, we held quite wide stakeholder consultations to identify barriers and opportunities for engaging youth and young professionals in policymaking. And then this resulted in a proposal to develop a best practice framework for engagement of youth in policymaking with a focus to address the science policy divide. So following on from COP27, our partners in our group will be working to develop this framework with representatives of the countries that have participated in the event, including Canada, South Africa, and Egypt. So here you can see a photo from the event. And also, members of our group were engaged in bilateral meetings at COP27 as well. And personally, I had the privilege of co-chairing a meeting between youth and the European Union, where we raised a number of issues, including on the engineering side. And we also met with a number of other country party representatives, including the COP26 presidency, where we raised an issue and proposals with regards to youth engagement. And finally, importantly, we continue to build partnerships in the built environment sector and really strongly supported the breakthrough agenda, which was led by the Building the COP coalition and the high-level champions. And with our work for COP28 and going forward, we're hoping to capitalize on those partnerships and really help strengthen the voice of the built environment sector in climate action by providing the voice and energy and innovation of young engineers. Thank you very much for your attention.
Thank you, Kirils. Thank you. And we are running a little bit behind schedule, and so I will pass to Valentina Putrino immediately as a representative of the Committee on Disaster Risk Management. Valentina, the floor is yours.
So, good morning, good afternoon, and good evening to our audience online from all over the world. My name is Valentina Putrino, and today I have the great honor and pleasure to represent the Committee on Disaster Risk Management, having as main role the one of minimizing the potential damage and risk to human life through the proper application of technology within the world of engineering. The committee is chaired by José Macaré, and it is constituted by 5 main subcommittees, namely land use planning, which focuses on guiding engineers with help of codes and regulation in decisions on land and water use, how to use the resources of the environment in a most beneficial way. Resilient infrastructure, which spins around the management to enable operational risks to be identified and mitigated. Data and information management, covering the important topic of digital information usage, storage, and sharing, to then convert it to actionable information to enable science-informed decision-making processes across the world. Capacity building, entirely focusing on building resilience to cope against today's fast-paced stressors against its development. And institutional frameworks, which evolves around the topic of defining the most suitable institutional structure to provide an adequate framework for the setup of public policies, governance, and actions. These themes are being developed through working groups, and today I'm here to represent the capacity building working group, which I lead. The Committee on Disaster Risk Management supports the World Federation of Engineering Organization and the engineering profession worldwide by encouraging countries to implement the Sendai framework for disaster risk reduction, with special focus on contribution to the Sustainable Development Goals 11, resilient cities, organizing international webinars, technical scientific events, and by disseminating publications related to their work within the strategic plan, developing and promoting disaster risk management policies, strategies, and practices to reduce disaster caused by natural phenomena, and strengthening the committee's visibility and presence in the public sector, academic institutions, and multilateral organizations. The work done by the committees fit the wider scope of COP27 by endeavoring to showcase the work, the research, and the tangible actions of professionals and academics, which can help and support the implementation of the global disaster risk reduction initiatives, which are at the core of the Sendai framework for disaster risk reduction 2015-2030 through the vehicle of engineering. Well, one could argue, how are we achieving this? The answer is simple. The more we are exposed to the effect of human-caused global warming, the more we need to act upon our readiness to withstand more frequent and less predictable natural catastrophes. And we do that by wearing our engineering hats and effectively by changing our perception of what is safe and what is not, and how we can devise best practices to get ready for the worst. We tailor our events such that important and very practical themes are discussed in this unstoppable chase for raising awareness. We've chosen topics such as engineering as a driver for the risk-informed development, where our invited speakers have covered the important topic of propagation of business continuity management plans, for example, to small and medium enterprises. In that event, for example, our academics from the Disaster Mitigation Research Center of the Nagoya University have analyzed the challenges brought by the Niigata and Quetzway earthquake in October 2004, an event that has affected the Japanese business sector for a very long time and at a very large scale. Their work has proven that building the foundations for small and medium businesses to believe in business continuity plans has been the real challenge, which has involved and is still involving a shift in the perception of the intrinsic risk linked with the concept of living in earthquake-prone countries. Another key example covered in our seminars evolves around the topic of strategy to reduce earthquake damage in developing countries. Our invited experts from the International Cooperation Agency showcased what happened in countries like Indonesia, the Philippines, Nepal, Bangladesh, when it comes to dealing with reconstruction after serious natural catastrophic events, and the challenges linked to the lack of highly advanced and country-specific building codes. The question answered in that occasion were, how do we blend the local know-how and local building traditions with more advanced and prescriptive codes such as FEMA or the Eurocode, for example? How do we deal with non-engineered structures which do have heritage value and very often possess the intangible power to represent local communities? Linked to the very important topic of the role that cultural heritage plays in building the sense of community, we have invited world-leading experts to a dedicated webinar entitled Strengthening Efforts to Protect and Safeguard the World's Cultural and Natural Heritage. The aim of that seminar was to understand how local community, no matter their geographic location or which type of resources they've made available, can come together as a whole and act upon the implementation of effective strategies to understand the resistance, stability, and conservation of monumental heritage pieces. However, the capacity building task group is not only made focusing on natural catastrophes, but also on man-made disasters, such as wars and political conflicts, which affect the community and cause even more permanent and deep socioeconomic damage. And this is where engineers need to wear their social and community resilience understanding helmet, exit their purely technical remit, and embrace the challenge of reframing their know-how towards the humanitarian assistance and disaster relief. Our very recent webinar entitled Engineering for Humanity, Cases of Afghanistan and Ukraine, was our best chance to show that humanitarian crises present the opportunity to take significant action towards enhancing building environment resilience, to reducing damage and facilitating recovery, whilst also saving lives and restoring communities. Our invited speaker, coming straight from months of recent field deployment, shared with us the very tangible results which they managed to achieve by literally going to talk to people, understanding the social implication of being displaced, relocated, and deprived of the comfort of their homes, the local facilities, the schools, the hospitals, and infrastructures, things that we usually take for granted. As you'd imagine, the Committee on Disaster Risk Management and all the task groups have a long way to go still. So much more is yet to be done, showcased and certainly made available to the wider community, with the aim of consolidating the concept of engineering as one of the engines that pushes community towards improving and enhancing resilience. And this is why I invite you all to continue to follow us, to attend our webinars, and to reach out if interested to become active players of this important task. And with this, I thank you for your attention.
Thank you. Thank you so much, Valentina. I can see that, you know, as we are moving on with the presentations, we are also starting to see the first questions in the Google Doc. So I will invite the presenters to have a look because there are some interesting questions there. The next presenter is going to be Ignacio Gonzalez-Castelao. He is the chair on the Committee on Engineering and Water, and there's clear links between climate change and water. So I'm pretty sure Ignacio will raise these issues. Ignacio, the floor is yours.
Thank you very much, Davide. Let me share the screen first. Good afternoon to all, and I'm going to talk about climate change in the field of water and the different adaptation actions that engineering provides. As I only have 10 minutes, I will give an overview of these adaptation measures, but if you want further information, you can download from the WFEO website the publication that you can see on the slide. Before addressing adaptation, I believe it is important first to take a look at current status of our resources. The amount of water on Earth has remained unchanged for more than 3 billion years, but our global demand has constantly increased. At present, demand accounts for 5% of the water in rivers and lakes. The current status of water resources can be assessed through UN Water's monitoring progress on SDG 6 targets. The average of all these progress indicators is 53%. This means that we need to accelerate action as we are not yet moving at the speed and scale needed to achieve the Sustainable Development Goals set for water. This current situation is exacerbated by non-climate factors such as population growth or production and consumption patterns. Also, the aging of some of our water infrastructures is also an issue to be considered. Climate change is an added problem to this current situation, increasing pressure on already stressed water resources. The degree of mitigation we achieve will determine the level and measures needed for adaptation. The more mitigation, the less adaptation, and we cannot all forget that beyond adaptation, there is only migration. The different climate scenarios expected simply indicates that the speed at which we must to adapt. Adaptation is not only constrained by physical limits, but also by the limits of knowledge, governance, and financing. These three pillars are fundamental. In addition to scientific knowledge, it is necessary to recognize the value of other knowledges, such as indigenous, local, or community science to understand and evaluate adaptation process and actions. Engineering is the one that materializes knowledge, making it available to society and the environment. Globally, adaptation costs in the water sector will amount over $20 billion per year by 2050. How much is this? Well, it's almost half of what has been paid for tutor. Equity consideration must be integrated into financing. If this does not happen, the adaptation gap will continue to grow. We are all, I think that we are all aware about the components of climate systems related to water cycle that are expected to change on a warmer planet. But I would like to highlight that while climate trends and effects at a global scale are clear, there are uncertainties when downscale to a regional, local, or basin level. Uncertainty related to future scenarios means that every effort should be made to adopt no regret or low regret measures. These are flexible or resilient approaches focusing on short-term, low uncertainty actions. We can group the main adaptation measures into three categories: those related to water supply demand, extreme weather events, and sea level rise. The term demand should be holistic and also refer to all other living beings and natural ecosystems. If we focus on adaptation measures related to water supply demand, we can say that climate change will affect water supply in terms of availability, quantity, and quality. The demand will be affected mainly by world population growth and the consumption patterns of the current development model. The balance between a reduced supply and increased demand can only be achieved through an adequate planning and integrated water resource management. 7 supply-side adaptation measures have been identified, and 5 demand-side adaptation measures are proposed. From the water supply point of view, we can say that increasing knowledge contributes to better uncertainty management and decision-making, transforming existing river basins into smart river basins. We must protect water at its source. Therefore, the protection and conservation of natural ecosystems should be clearly incentivized to determine water prices and the strategic protection of land. Water losses reduction is one of the non-regret measures I referred about earlier. Measures to improve drainage and sanitation networks, together with wastewater treatment, should be a priority, not only just from a climate change perspective, but also from human health and environmental perspective. Storage and regulation capacity is important to increase supply and make it available when demand requires it. Rainwater harvesting, wetlands, reservoirs, and aquifers recharge are the main measures. And conventional resources such as atmospheric water capture, desalination, or reuse allow the release of other resources and diversify water sources. Almost 2.5 billion people live less than 60 miles away from the coast, so it seems that desalination will continue to be an indispensable resource in the future. The linear model of water catchment, storage, transport, potabilization, distribution, use, wastewater treatment, and discharge changes completely by including water reuse, generating a circular water economy that increases the capacity for sustainable adaptation. Space stations are the paradigm of reuse in the field of water to provide astronauts with this resource. More water should be reused than what is currently done, because there is a large circularity gap. Believe it or not, the same is true with the reuse of materials. Currently, only 8.6% of the world's materials are recycled. The last but not the least of the 7 supply-side adaptation measures is the transfer of resources between regions of basins. This transfer is also carried out through the import and exporting of goods, products, and services, the so-called virtual water. Regarding demand-side adaptation measures, all of them are aimed at making better use of water resources. Implementing awareness campaigns on sustainable water use, particularly in agriculture, is a task in which we all must actively participate. Increased knowledge is essential for decision-making regarding the opportunity of water consumption. Other demand adaptation measures are aimed at increasing the productivity of the resource. The reduction of losses from a demand perspective is also relevant. And the last measure, and perhaps the most important, are all those advances that make it possible to decouple development from water use or disruptive changes that promote less water consumption. These advances will release resources and ensure that water is not a limiting factor for development, increasing the planet's biocapacity. In human history, changes normally follow technological breakthroughs, but in the case of climate change, the opposite is happening. Change is taking place first, and technological solutions are lagging. We are providing traditional solutions, and we need disruptive breakthroughs. Now we're going to talk about the adaptation measures from extreme weather events. Catastrophes are increasingly seen by society as the public face of climate change. Climate extremes cause extreme events, but whether a meteorological phenomenon is catastrophic or not does not depend exclusively on the extreme value taken by the climate element. Other factors, mostly caused by economic and social reasons, are the ones that can condition the catastrophic nature of an extreme phenomenon. Traditionally, these extreme events have been treated as an emergency or critical situations. The policy are changing worldwide, shifting from a crisis management approach to one based on risk or adaptive management. Since 1970, 44% of all disasters in 31% of all economies losses have been flood-related. This risk must be addressed with structural and non-structural measures. Basins that host numerous flood protection infrastructures have, in many cases, lost the connection between rivers and floodplains. In this case, it is important to recover the natural retention measures if possible. Since 1970, 7% of disaster events worldwide have been drought-related. However, they contribute to 34% of disaster-related deaths, mainly in Africa. Addressing drought risk is based on establishing management plans and measures, drought controls, and warning systems. More details on this issue you can find in WFEO's publication shown on the slide. The last measure addressed are those related to sea level rise. Given that sea level will continue to rise regardless of the mitigation measures undertaken, adaptation seems to be a priority. It should be noted that 10% of the world's population lives between 1 and 10 meters above sea level. If we focus on small islands or atolls, it should be noted that in addition to facing rising sea levels, they are already facing water insecurity that will increase in the short term. Therefore, an international collaboration to address climate change on these sites is essential. We cannot forget that climate change must be a shared change. Adaptive response can be categorized in 4 groups: coastal protection, advanced adaptation, and retreat. Usually, these measures occur in combination with each other at the same coastal location over time. Coastal protection measures may be cost-effective for cities, but not affordable for rural and poor areas. In terms of coastal development, over the last 30 years, around 34,000 square kilometers of land has been reclaimed from the sea. Adaptation measures proposed are not only structural, but also those related to the establishment of new building codes, better planning, the development of forecasting, and early warning systems. Accommodation measures can be efficient in places where small rises in sea level are expected. The last one, the coastal retreat, is an effective solution, but has a serious social and political problem. Well, the adaptation measures described bring multiple benefits, but we must build infrastructure from a different perspective, putting more value on the relationship with the rest of the stakeholders, such as the environment. Therefore, the design step or phase is fundamental. We must design resilient and non-regret infrastructures, identifying vulnerable areas and testing our proposals for adaptation to climate stress tests. The circular economy of water is important, but it's also relevant to consider the life cycle of the materials we use, defining at the design stage the dismantling of facilities at the end of their lifespan and their possible subsequent use and recycle. We engineers must continue to be the actors in this adaptation to change and also the transformation of the development model. Thank you very much, Davide, and the floor is yours.
Thank you, Ignacio. Thank you. Very interesting. We can start seeing some common themes among all the different presentations that we had so far. Demand side, about the water and energy, circular economy again, between the energy and water, but also the disaster aspects, the adaptation aspects with the disaster risk management. So we are moving from Madrid in Spain to Beijing in China now with the next presenter, who is Professor Jianping Wu. He is a representative of the Committee on Engineering and Environment, and he's working on a very important project on climate change mitigation. So, Professor Wu, the floor is yours.
Thank you. Good morning, good afternoon, and good evening to all. It's my pleasure to be here to present the WFEO Climate Change Mitigation Best Practice Project to you, representing the project team. My name is Jianping Wu, a professor in Tsinghua University, Beijing, China. Okay, the presentation covers the 6 aspects. First of all is the aim of the project. As you know, WFEO is the engineers organization. It has over 100 member countries. So this work is try to make the best contribution to climate change from WFEO. So the way is, how do we do that? We are going to collect the successful project examples from all the WFEO member countries of their successful engineering project. And then based on that, we will select and share those the best practice project to all the WFEO member countries. What we are going to do, the project focus on civil engineering and the construction side. The reason is that it accounts for 36% of the global final energy use and around 40% of energy-related CO2 emission. So the project, what we are going to do will include the 5 aspects. First of all, we are going to build a database to hold all the data we collect from our member countries, and then the database will open to all WFEO member countries. And regularly, based on the data we have, we will publish reports to all the member countries. And then we will produce technical guidelines based on the study of the data, and to hold an international conference and workshops, and to provide training courses when it is needed. To collect the data efficiently, and we designed the questionnaire. The questionnaire we designed will include the 7 aspects, which include building design or engineering design, 2, building materials, 3, construction engineering, 4, building operation, 5, reconstruction, 6, waste, building wastes, 7, the macro indicators. The project, to properly push the project forward, we divided the project in 2 phases. In phase 1, we selected a small scale, small group country to test the questionnaire. The first phase, we selected 8 to 10 countries to participate. Based on the success of this small scale test, we will send the questionnaire to all the WFEO member countries, which will include over 100 national organizations and countries. Okay, so this is the first phase. We select the 8 countries to participate. So far, we have already collected back the questionnaire from 3 countries, which includes all the 6 aspects, including design, materials, construction, operation, reconstruction, and the waste. Based on the data we collected, we made a parallel comparing between, for the same question, based on the data come back from different countries. For example, this right table, we compared the new methods to reduce the level of energy consumption and the carbon emissions of traditional building materials and the application cases. So here we compared the information come back from China, from Peru, from Malaysia, and the left side is as well, which compares innovation on designs. Here is an example which focus on the energy saving on building materials. For example, I just summarize here. For example, China will focus on developing energy saving building materials, such as low radiation coat glass and solar power generation materials, or high performance thermal insulation materials, for example. Peru will focus on concrete partly taken from secondary raw materials, and on new type of cement, and such as silicate CO2 replacing traditional varieties, and bioaggregates based on organic materials. Malaysia will focus on use of skylights, windows, which will allow significant amount of daylight into the office space. Using the state-of-the-art lighting accounts for approximate 40% of energy used in typical commercial building, and properly execute daylighting strategy can reduce HVAC peak loads. So that is just one example. We comparing the data come back from different countries. So we have so many data come back now, and based on the questionnaire come back, we also noticed something we need to improve. So for the questionnaire, later on when we send out, we will use more tables and use a designed template, so to collect more accurate and data. And also we will focus more application case and successful case from all the country. And we also have a template for that. It will include the text for the project description and a picture, a graph, and some indicators. Okay, so next we will further analyze based on the data we come back, because each questionnaire includes a large amount of information. So we will then further, based on that, we will do more questionnaire sending out to our WFEO member country to hope for to collect more data come back. So the project team, now we work under the project support from Tsinghua University. And now we also have some other offers for funding and donations coming. So we are looking for more supports from UN and from WFEO member country and from all the foundation organizations for your support to this excellent project. So thank you for your attention. Yeah, that's from me.
Thank you so much, Jianping. And I think that, needless to say, this is a really important project for all of us. And so we'll come back to the UK in a moment. But before doing that, from Beijing, we move to Melbourne in Australia, where our past president, Marlene Kanga, recorded an intervention. She couldn't be with us because effectively it's a bit late in Australia right now. And tomorrow morning she has a very early morning rise. So she sent this video that Ivan is going to share with all of us.
Good morning, good afternoon, and good evening, everyone. And thank you for joining this WFEO webinar on engineering and climate change. It gives me great pleasure to speak here today on this very important topic and to give you an insight on a project that has been recently delivered on behalf of WFEO. I will first try and share my screen. My topic today is From Visions to Actions with Impact, Climate Change Education in Small Island Developing States through Curriculum Development and Teacher Training in Schools. Firstly, a little bit about the World Federation of Engineering Organizations. We are the peak international body for professional engineering institutions, founded in 1968 under the auspices of UNESCO. Our members are some 100 national professional engineering institutions and 12 international and continental and regional professional engineering institutions, together representing approximately 30 million engineers. We are the co-chair of the major science and technology group at the United Nations, along with the International Science Council. And we have representation at all major UN organizations, including the UNFCCC and the Committee of Parties, the COP meetings, including COP27 that was held recently. Since November 2017, when I commenced my term as president of the World Federation of Engineering Organizations, the Federation has had a vision and a message that every one of the UN Sustainable Development Goals can be advanced through engineering. This was brought to fruition in a declaration in Paris on our 50th anniversary in March 2018, where we expressed our commitment along with UNESCO to advance the UN Sustainable Development Goals through engineering. And this declaration had three important parts. Firstly, to increase the number and quality of engineering graduates. Secondly, to inform global standards for engineering education and support the development of a range of engineering education systems that comply with these agreed standards. And thirdly, to support capacity building through strong institutions for engineering education. And the project that I will speak about today will show how we are progressing this vision into action. The Secretary General of the United Nations, Antonio Guterres, himself an electrical engineer, also supports this vision and sent us a message in 2018 on our 50th anniversary, saying that every one of the goals requires solutions that are rooted in science, technology, and engineering. Our current president of WFEO, Professor José Vieira, also espouses this vision. He has stated in a message to a workshop that I will be speaking about today that WFEO has been continuously advocating in favor of training more engineers, technicians, and educators so they can have the right skills to be up to the task of fighting, mitigating, and adapting to climate change, especially in countries which face the most consequences of it. Training educators, mentoring engineering educational national systems in order to bring harmonization and standards are the main pillars of the strategy, and this workshop is the perfect example of its implementation. The workshop that I'm going to speak about is a partnership for climate change education in primary and secondary schools. The partners include UNESCO, the World Federation of Engineering Organizations, the Office of Climate Change Education, which is a Category 2 UNESCO center, the National Environment Agency of Singapore, the Mauritius Ministry of Education, Tertiary Education, Science and Technology, the Mauritius National Commission to UNESCO, the Mauritius Institute of Education, and the Institution of Engineers Mauritius, a national member of the World Federation of Engineering Organizations. So you see here, we have a combination of international and national organizations that have come together to collaborate and deliver on this important project. So what is the Climate Change Education Project? The objective was for curriculum development and teacher training in climate change, for world-class climate change education for primary and secondary schools in Mauritius. This project is a blueprint for future projects that we hope to run in other small island developing states with the same partners. Planning for this project commenced in September 2019, but in-person delivery was delayed due to COVID. We had a first session virtually on 29th and 30th June 2021, which was attended by some 80 teachers from around Mauritius and the island of Rodriguez. A second session was completed just last week from 22nd to 25th November and in person in Mauritius. This project was made possible with a generous donation of $10,000 US from the WFEO Innovation Prize, which was awarded to the National Environment Agency of Singapore in November 2019. The agency donated the prize money for this project because it aligned with so much with its objectives. It took 3 years to deliver, but remained focused as a result of the passion and dedication of all the representatives of the partners that were involved, and my sincere thanks to them. So who are the partners? The Office of Climate Change Education was created in 2018 as an initiative of Lamana Lapat Foundation and the scientific community as a response to the global need for climate change education. Mr. Erid Goliadi is the president of OCE, a climatologist and lead author of the IPCC reports. In 2020, the OCE became a Category 2 center under the auspices of UNESCO. OCE aims to promote climate change education at an international level, with a special focus on emerging countries. The climate change education is promoted through quality education resources based on IPCC reports, where OCE is an official observer, and which emphasize interdisciplinarity and active pedagogy. A professional development program to familiarize teachers with climate science, active pedagogy, and project design, and the design and implementation of national and international operational projects. Other partners in this project were the Institution of Engineers Mauritius, the National Professional Engineering Institution for the country, and a national member of the World Federation of Engineering Organizations. The Mauritius Institute of Education is a degree-awarding teacher education institute of higher learning with the mandate for educational research, curriculum development, and teacher education in pre-primary, primary, secondary, and tertiary education in the Republic of Mauritius. The National Environment Agency of Singapore is a leading public organization responsible for ensuring a clean and sustainable environment for Singapore. Its key roles are to improve and sustain a clean environment, promote sustainability and resource efficiency, maintain public health standards, and provide timely and reliable meteorological information. You see here some screenshots of part 1 of the virtual meeting that was held in Mauritius from 29 to 30th June 2021. We have Mr. Shyam Roy, then president of the Institution of Engineers Mauritius, delivering the welcome, and Dr. Ravi Bola, associate professor and head School of Science and Mathematics, Education for Sustainable Development coordinator, Mauritius Institute of Education, and a key person who collaborated with us for the last 3 years in delivering this project. You see here Dr. Simon Klein in the top left-hand corner, who presents information from the Office of Climate Change Education. Dr. Klein has been also a key collaborator with us in the last 3 years and has delivered not only the virtual event, but also the in-person event in Mauritius. There was keen engagement by the teachers that attended the virtual meeting. You see here a teacher from Mauritius asking a question during the Q&A sessions in the 2 days of the sessions that were held in 2021. Here we have the flyer for the in-person workshop that was held from 22nd to 25th November 2022. And you see here at the top of the flyer, the acknowledgement of the 6 important partners, both international and national, that came together to deliver this important project. The Climate Change Education Project Part 2 involved hands-on learning, including with the UNESCO Sandwatch teaching materials. Sandwatch is a voluntary network of children, youth, and adults who work together to enhance their beach environment and build resilience to climate change. Sandwatch has a well-illustrated manual in various languages, and Sandwatch groups select to investigate different aspects of the beach, such as beach erosion and accretion, sediment composition, impact of human activities on the beach, beach debris, pollution, water quality, waves, currents, plants, and animals. And you can see more at the links that I have provided. The Office of Climate Change Education has world-class training materials developed by experts. And you see here 3 examples on ocean and climate change, developing a sequence of lessons from a conceptual framework and understanding the greenhouse effect. A large volume of printed copies of training materials and resources were shipped to Mauritius for the teachers for the in-person session last week. And here we have the outcome, the final day of the event that was held last week. We have the training for primary and secondary school teachers from Mauritius and Rodriguez, training for teacher trainer, and most importantly, curriculum development for ongoing teaching of climate change causes and effects. Demonstration of the use of UNESCO Sandwatch and other OCE teaching resources were also included. And we are hoping that this will deliver long-term benefits for the people of Mauritius. Thank you very much for your kind attention.
Thank you, Marlene. Thank you for addressing the audience and all of us about the importance of capacity building on climate change. And the very final presenter is going to be Dawn Bonfield, who is going to talk about women in engineering. Dawn.
Thank you very much, Davide, and thank you everyone for staying with us till the end. So my name is Dawn Bonfield. I'm Deputy Chair of the Women in Engineering Committee, and I'm going to tell you a little bit about the role of our committee in relation to climate change. I'm from the UK. I represent the Institution of Civil Engineers in the UK. And just to give you a little bit of background on the Women in Engineering Committee, we have two themes that look at capacity building, just following on from what Marlene was talking about in terms of numbers of women coming into engineering, and also their retention within engineering, their progression and route to leadership positions. Also building an inclusive engineering culture within the engineering sector itself. The third theme there is all about using our global network that WFEO represents to do some benchmarking. So look around the world and see what the numbers of women in engineering look like around the world. But specifically for this particular discussion today on climate change, theme 4 there is a piece of work that we do using the gender perspective and looking at the Sustainable Development Goals in relation to that gender perspective. And I'm going to try and move on one slide. Okay, so what we're doing is, if you see the glasses on the top left there, we're using this gender perspective and going through each of the Sustainable Development Goals in turn. And then from there, as you see, climate change number 13 is the one we're focusing on today, but from there we're getting a sense of what engineering, what that means to us as engineers, and how we can take gender inclusive action when we're looking at climate change mitigation and adaptation. So this is a work in progress. So we are, as I say, looking at each of those Sustainable Development Goals in turn, and we're producing these information banners, if you like, posters, and this one here is in the corner of my office at work, which you would see if I were there today. But it's trying to bring that conversation into the engineering sector that we don't often hear. And one of the things that we do by attending the COP meetings is we represent ourselves there. You know, we're a committee of engineers, obviously, so we're there to represent the work that we do as engineers around climate change. But we're also really importantly there to listen and learn from those women who are represented there at meetings like COP, and then take away the learning that we've gained from those conversations that we listen to and translate it into our world as engineers. So making sure that any solutions that we come up with in any sector, you know, we've heard it today from a number of speakers, but making sure we're bringing that reminder that women often play very different roles in society, and as such they need solutions that are understanding of those roles and that allow them to access the solutions that we're proposing. So representation, we've got a group of people that go along. I go from my own Women in Engineering Committee, but a number of us are there from the various other committees of WFEO, representing their work, their own work, and the work of other organisations they're involved with that we partner with. So listening and learning, you know, I spend a lot of time listening to the oftentimes the Indigenous women who are at these meetings, telling us what is really important to them. You know, probably one of the strongest messages we heard at COP27 this time was around land rights, and how women are not owning their own land, and how difficult it is then for them to take on that stewardship and get any kind of grant funding that allows them to use some of the technologies that are being developed and apply them to the land unless they own the land themselves. And also when they're displaced by climate change events, they don't get the help that they need if they're not landowners. So that came out very strongly this time. Women are represented by a number of groups at meetings like COP. One of them is called the Women and Gender Constituency. And that's a little bit like Kirils was speaking about earlier, the Youngo group, which is a civil society group representing young people. This is a group representing women and gender. Another thing that is quite strong at these climate change events is the UN Women's Action group called the Feminist Action for Climate Justice, and lots of countries are now signing up for this this particular action coalition. And in fact, the UK signed up at COP26 last year. And what that looks like is that people are bringing in these gender perspectives into their nationally determined contributions, and you know, or they're kind of committing to bringing this gender perspective into anything that they do around climate change, whether it's loss and damage, mitigation, adaptation, around everything. We, by the way, have not, as an organization, have not signed up for this particular Feminist Action for Climate Justice commitment, but what we have signed up for as a Women in Engineering Committee and as an organization is another of the action commitments called Technology and Innovation for Gender Equality. And that speaks to target 5B of the Sustainable Development Goal number 5, which is gender equality. So this is all around enhancing the use of enabling technology, in particular information and communication technology, to promote the empowerment of women. So we have made a commitment to make sure that we are bringing and representing that voice of women in the engineering and the technology work that we do. So just very, I think I probably don't have time for this, but I was going to speak about the way that women are affected by climate change in terms of having to go further for water and fuel, and in terms of drought, in terms of gender violence against women and girls, in terms of caring for people who are sick as a result of climate change. But also another important aspect is around their behavior. And if we're talking about bringing in any technologies, then we have to be, or policies, we have to be aware of how people's behavior needs to accept those technologies. And women are a very important part of that discussion, because they're very often the gatekeepers of their home systems and their heating and their waste systems and their purchasing power. So it's really bringing this voice of gender into the conversations that we have as engineers. Just very quickly, we saw the Earthshot Prize winners in the last few days, and out of the 5 winners of the Earthshot Prize, we see 2 of them are directly related to women, so women in Kenya and the clean stoves, and also the indigenous women of the Great Barrier Reef, but also the number 2 there around local smallholder farmers, of which very many of them are women, and how they get additional finance and funds to be able to use this sort of new technology that is being introduced. So that's a very, very quick run through of the work of the Women in Engineering Committee, because I see how close to time we are, but just basically we are there to, we're there as engineers, but we're there to also listen and learn on the way that climate change is affecting women around the world, and make sure we take that into account with our engineering solutions. So if you do want to get in touch with me or the committee, then my email is there. So back to you, Davide. Thank you, everyone.
Thank you, Dawn, and sorry for rushing you a little bit, but I guess that your message came quite strong and loud. So first of all, I would like to thank everybody, really, from the presenters to the audience, to, you know, keep this hour and a half in your calendars. And I hope you actually got the message that effectively WFEO is quite active on the climate change aspects, and there are lots of different, you know, facets. So get in touch with us. I think in the chats there were all the different links to the different committees, to the WFEO pages. that are constantly updated. So my invite for all of you is effectively to regularly visit these web pages. And I think that being on time, being engineers, we want to, you know, to really want to thank you, all of you, for being with us again, presenters included. And we wish you a great day wherever you are. And thank you again.